Hello, my name is JaCoya Thompson, a PhD student in the Computer Science Department at Northwestern University. Today, I'll be talking about using Python in an advanced placement statistics class. Python is a text-based programming language that allows professionals to analyze, visualize, and modify data. It can also provide high school students with a new way to express statistical content. We investigate integrating Python in an advanced placement statistics class. The goal is to design and study if Python can help students engage with and understand statistical content and explore ways teachers can design lessons using Python. A high school AP Stats teacher and I co-designed a unit that included 3 Python integrated lessons on descriptive statistics. The lessons built off of one another, allowing students to gain more confidence with Python over time. Using Python libraries, pandas, and matplotlib, Jupyter notebooks for each lesson serve as an interface to modify, debug, and re-execute code on a given dataset. Students use a Python scaffolded so the setup time between teacher and student is minimum and to support a smooth transition. Now, I will briefly describe the lessons. The first lesson, students begin to familiarize themselves with Python and the various commands and functions in Jupyter Notebook. Students receive a dataset and run the code in the notebooks. First, generating a descriptive table, students interpret the mean, standard deviation, and the quartiles. Students then generate a box plot. They identify the length of the box and the descriptive statistics that is not shown on a box plot. Last, they plot a histogram. They describe the distribution, shape, center, spread, and outliers, and they identify the descriptive statistics not shown on a histogram. Students can change the color and bin count of the histogram to further familiarize themselves with Python. The next lesson, students analyze one of 5 datasets that may relate to their lives. In this example, the dataset is number of Instagram followers. One part of the code is written, and students have to use the code from the previous lesson and debug to get results. In this lesson, students generate a descriptive table and make predictions of what the histogram will be using the mean and median. As before, students plot the histogram, describe the distribution, shape, center, spread, and outliers. Students adjust the bin width and explain which bin width best fits the dataset and why. Finally, students produce a box plot. They interpret the descriptive statistics shown on the box plot versus what is shown on a histogram. Before this last lesson, students completed a survey. The teacher compiled datasets by period and asked students to make comparison between the 2 classes. Again, students have to complete the code or debug to get results. Students plot descriptive tables, histograms, and box plots. Then students have to remove values from both of the datasets that are closest and furthest from the mean. After each change, they rerun the code to produce descriptive tables. This is to help them observe and interpret how the standard deviation relates to the mean. This chart shows correct and incorrect responses to questions in each lesson. Results show that most students correctly interpret the values for mean, standard deviation, and quartiles. Overall, most students showed an understanding of distribution, shape, center, spread, and outliers. We observed that in Python Integrated Lesson 1, some students struggle with interpreting what is shown or not shown on box plots. But by Python Integrated Lesson 2, most students could interpret the difference between the information shown on a box plot versus a histogram. This is one example of how Python can be embedded into an advanced placement statistics course. We provide students the opportunity to explore data sets in depth, showing how different graphs of the same data can provide different information and interpretations. Students had some difficulty understanding how Python worked, and this led to some frustrations when they would get minor syntax errors. But Python can change the atmosphere of a classroom from one where students are not accustomed to making mistakes to one in which mistakes can lead to reflection and investigation. Overall, we were able to engage students with real-world data analysis without hindering their understanding of the statistical content, and also share the power of programming with students who would not normally engage with it. Thank you for your time. All questions and comments are welcome.